It began with silence, not the absence of sound as we know it, but the deeper quiet of a universe whose earliest whispers had been stretched thin by expansion, thinned into an invisible murmur of microwaves. Into this quiet, humanity opened a golden eye, the James Webb Space Telescope, a mirror of beryllium and gold suspended far beyond the Earth's atmosphere, poised to gaze where no other had gazed. Its purpose was modest on the surface, to trace the light of the first galaxies, to peel back cosmic history, yet what it saw would rupture the fabric of expectation, as though reality itself had left a message inscribed in light. When its detectors turned toward a region beyond the great galaxy clusters, deeper than the Hubble ultra-deep field, the telescope expected chaos. After all, the early universe was meant to be a murky fog, hydrogen clouds, faint glimmers of the first stars, irregular structures barely coalescing. Instead, what arrived on the instruments was an arrangement too deliberate, too precise. Buried in the faint red glow of ancient photons was not a galaxy, not a star-forming nebula, but a symmetry, a pattern. It was the kind of pattern that nature avoids unless compelled, a repeated echo of geometry, nested like Russian dolls in the noise of background radiation. Scientists pored over the data, dismissing the first analysis as an artifact of software. Yet the repetition persisted, prime numbers hidden within waveforms of light itself, like a rhythm coded into the heartbeat of the cosmos. The photons had traveled for more than 13 billion years to reach us, carrying within them an impossible message. What force could have imprinted such coherence at a time when even atoms were scarce? The discovery carried the unsettling implication that consciousness, or something akin to it, had been written into the universe long before planets cooled or DNA spiraled into being. The paradox was staggering. Our models spoke of randomness, of initial fluctuations amplified by inflation into the great web of galaxies. Yet within this chaos lay a trace of order, as if the universe had been punctuated by intention. To find such a pattern where none should exist was like hearing a human voice embedded in the static of a distant radio hiss. And it was not any voice. The structure of the pattern mirrored the architecture of neural connections in the human brain, firing across synapses that did not yet exist when the light was first released. The James Webb Space Telescope had not merely looked into the past, it had uncovered something that felt like a reflection. How could the ancient universe mirror the anatomy of our own cognition? Was the pattern a coincidence, the statistical ghost of human imagination? Or was it the trace of a deeper order, one that transcends biology, one that renders consciousness not a byproduct of evolution, but a property of the cosmos itself? The enigma spread like wildfire through hidden channels of academia. Official reports were careful, sterile, clothed in language of unexpected coherence and unresolved anomalies. Yet behind closed doors, physicists and cosmologists could not shake the uncanny weight of the discovery. Some whispered that it resembled a code, a language older than stars. Others feared it was a mirror held up to our own minds, as though the act of observing had drawn out the image of the observer. Could it be that the universe is recursive, folding upon itself like thought, and that when we look deep enough we are destined to find ourselves staring back? History had warned of paradigm shifts born from looking farther than intended. Galileo, pointing his crude telescope at Jupiter, discovered moons in orbit, and with them the collapse of geocentric certainty. Now the James Webb Space Telescope risked collapsing another certainty, that the cosmos is indifferent, blind, mechanical. If order had been etched into the chaos before order was possible, then what did that mean for the story of existence? The enigma reverberated beyond the halls of science. Philosophers revived ancient questions. If the universe is inscribed with mind-like patterns, does that imply an author? Or does it imply that mind itself is not a product, but a principle? Theologians, physicists, and mathematicians, usually locked in separate debates, found themselves orbiting the same question. What if the laws of physics are not merely equations, but sentences? What if reality is not only describable by mathematics, but written in it? Consider the timing. The photons were born more than 13 billion years ago, when the first light broke free from opaque plasma. For eons they traveled through expanding void, slipping past dark matter scaffolding. redshifting into invisibility. They could have struck rock, been swallowed by dust, absorbed by gas. Instead, they crossed the abyss unimpeded, destined to collide with a machine built by a fragile primate species, suspended at a gravitational balance point 1 million miles from home. What are the odds that light carrying this impossible symmetry would survive to meet an intelligence capable of noticing? Chance or conspiracy of physics, the symmetry was not loud. It did not announce itself with clarity. It was subtle, nested in faint deviations in the spectrum, the kind of thing that only persistence and improbability could reveal. But once seen, it could not be unseen. It was like standing at the edge of the ocean and noticing, hidden among the waves, a perfect spiral repeating again and again, too exact to be coincidence. The cosmos, it seemed, was whispering, but whispering in a tongue we half recognized, like an echo of ourselves that had traveled from an age before we were born. Was it possible that the universe in its earliest moments carried within it the architecture of thought, waiting to bloom in creatures like us? That intelligence was not an accident of chemistry, but an inevitability, inscribed into the fabric of space-time itself? If so, then the James Webb Space Telescope had not only revealed galaxies and stars, but unveiled a more dangerous possibility: that we are not inventing meaning, but rediscovering it. That every neuron firing in the human brain is not a random flicker, but an echo of a cosmic pattern that has existed since the first light. And if that is true, if the universe encodes its own awareness in the very fabric of its expansion, then what else is hidden in the darkness? What other messages lie in photons not yet captured, in signals too faint for our machines to detect? If consciousness is woven into the stars, then perhaps the silence we hear when we search for other civilizations is not silence at all, but a form of waiting. The golden eye continues to stare, relentless, pulling light from the abyss, turning it into data, into images, into revelations. But perhaps the question is no longer what we will find out there. Perhaps the question is what will awaken in us when we finally understand what we are seeing. For if the cosmos has written mind into its first light, if the very shape of our thoughts was present at the beginning of time, then one must ask, when we gaze into the universe, are we discovering it, or is it discovering us? The universe, as science tells it, began with an explosion of possibility. A singularity, dense beyond imagination, erupted in an instant, expanding faster than light, releasing space and time together in a cascade of energy. From this expansion came the smooth background glow we still see today, the cosmic microwave radiation stretched across the heavens like an ancient fossil of fire. Gravity sculpted the energy into matter, matter into atoms, atoms into stars, and stars into galaxies. In the accepted story, there is no script beyond physics, no hidden author, only particles, fields, and forces shaping themselves by the blind arithmetic of chance and necessity. This is the prevailing paradigm. The Big Bang is not myth but measurement, written into the expansion rate of galaxies, into the cooling of primordial radiation, into the abundance of hydrogen and helium traced across the skies. From these beginnings arose the scaffolding of dark matter, invisible yet gravitationally essential, upon which galaxies could gather. Stars ignited from collapsing clouds, forged heavier elements in their cores, and detonated as supernova, scattering iron, carbon, and oxygen. These atoms, drifting across light years, seeded new stars, new worlds, and eventually planets where chemistry could begin its slow climb toward life. Abiogenesis, the origin of life from non-life, completes the chain of logic. Given a planet in a habitable zone, liquid water, and the right elements, complex chemistry can organize. Simple molecules energized by lightning or hydrothermal vents link into longer chains. Among these chains, some fold into forms that replicate. And replication, once it begins, is relentless. It copies, it mutates, it evolves. Across eons, life arises not by miracle, but by chemistry stretched over time, an emergent property of matter when conditions are favorable. From this foundation, evolution explains diversity. Random mutations filtered by natural selection generate the astonishing tapestry of organisms. From single-celled archaea to multicellular beings, From trilobites in ancient seas to primates in forest canopies, life adapts, shifts, survives. And within that adaptive framework, intelligence emerges. Human beings are not accidents, we are told, but one branch of a long and contingent tree. There may be others elsewhere, but they too would arise by the same principles: chemistry, replication, selection, survival. Cosmology complements biology. The structure of the universe is not arbitrary, but describable by laws. Relativity dictates the curvature of space-time. Quantum mechanics governs the dance of particles. Thermodynamics limits what is possible. The elegance of mathematics is remarkable, but the prevailing view remains one of indifference. The cosmos is comprehensible because it follows consistent rules, not because it holds intent. Stars burn their fuel, black holes swallow light, galaxies collide. Nowhere in this story is there necessity for design or hidden meaning. The James Webb Space Telescope itself was launched under this assumption. Its purpose was to observe the earliest galaxies, to test models of star formation, to refine the age of the universe. It was not meant to seek messages, not meant to encounter reflections of mind. It was a tool of conventional science, built on centuries of progress: Newton's mechanics, Einstein's relativity, Hubble's expansion, Gamow's primordial fireball. Every step led to the conviction that the universe is explicable by observation, experiment, and the consistency of natural law. This paradigm is powerful because it works. Predictions are confirmed, the cosmic microwave background measured to exquisite precision, exoplanets discovered by transit and wobble, molecules detected in the atmospheres of distant worlds. The accepted world explains why galaxies cluster, why stars shine, why DNA spirals in its double helix. It leaves no gaps for intention. In this telling, the cosmos is blind and vast, and our place within it is fragile but explicable. We are chemical consequences of a physical beginning, ephemeral sparks of matter, briefly alight in a cold and endless dark. It is a worldview of elegance and austerity. In it, there is no destiny, only process. The universe expands toward entropy, stars exhaust their fuel, life arises and fades, civilizations may bloom and collapse. The great story is one of inevitability without purpose. Hydrogen ignites, carbon forms, evolution selects, and eventually, death awaits all structures, from the smallest organism to the last galaxy. And yet, within this framework lies its quiet paradox. For how does matter, indifferent and blind, give rise to beings who can question indifference? How can atoms, obeying physical law, begin to wonder whether there is something more than law? If the cosmos is devoid of intention, how does the human mind emerge with the capacity to imagine intention everywhere? The accepted story provides answers, but also silences. It grounds us in physics and chemistry, but it does not speak to the unease that arises when we notice patterns where none should exist. It insists that what we see is what is, that all mysteries will dissolve into equations. But if that is true, then why does the light from the edge of time carry with it the architecture of thought? Why does the abyss sometimes look back? The scientific consensus is steady, confident, and vast. Yet confidence can be brittle when even one anomaly slips through. And as the James Webb Space Telescope peers farther still, one must ask, is the paradigm we hold complete? Or have we mistaken a fragment for the whole? For a time, the accepted narrative seemed untouchable. Measurements confirmed the expansion rate of galaxies, the background radiation mapped with exquisite detail, the synthesis of light elements predicted with precision. The paradigm held, but only because certain questions were set aside, certain irregularities ignored, certain whispers dismissed as statistical noise. Yet the deeper the James Webb Space Telescope reached into the abyss, the more difficult it became to dismiss. The cracks were not loud, but they multiplied, hairline fractures running through the foundations of the cosmos we thought we understood. The first came in the form of galaxies too mature, too luminous, too well-formed for their place in time. According to the prevailing model, the earliest epochs should have been marked by chaos, clumps of gas, dim proto-galaxies just beginning to coalesce. But the telescope revealed immense spiral structures already spinning in the first few 100 million years. Their existence mocked the timeline. To have such order so soon was like finding an oak tree growing fully formed a week after planting an acorn. The models bent, but they did not break. Astrophysicists spoke of unseen mechanisms, of dark matter scaffolds accelerating formation. Yet the suspicion lingered: what if the timeline itself was wrong? Then there was the question of light. Some of the earliest spectra contained chemical signatures too complex, elements heavier than helium that should not have existed in such abundance so soon after the Big Bang. According to stellar evolution, those elements require generations of stars to forge them and spread them across the cosmos. But the evidence showed them present at the dawn, as though the universe had skipped steps, as though it was impatient with its own rules. The phrase metallicity anomaly entered technical papers, but the words only disguised the unease. Nature was not following the script we had written for it. Even the cosmic microwave background, that grand reliquary of origin, revealed small inconsistencies. Tiny fluctuations appeared sharper, too organized, not entirely random. When filtered through algorithms, certain alignments emerged stripes and circles where chaos should have ruled. Some dismissed them as artifacts of data processing, but the patterns persisted across independent analyses. The universe, when viewed with enough precision, seemed less like an accident and more like a canvas with brushstrokes. Who or what was painting? Closer to home, the anomalies multiplied in biology. Abiogenesis, the rise of life from chemistry, remained a hypothesis supported by plausibility, but never demonstration. Despite decades of experiments, no laboratory had recreated the full transition from inert molecules to a self-replicating cell. The Miller-Urey experiments had sparked amino acids from lightning and gas, but life remained elusive. More troubling were the statistics, the odds of a functional protein emerging by chance from random sequences were astronomically small. To assemble DNA, RNA, and proteins into a self-sustaining system seemed less like inevitability and more like improbability balanced on a knife's edge. Yet life appeared early on Earth, almost as soon as the planet cooled, as if it had been waiting. The telescope added to the disquiet by detecting carbon-based molecules in the atmospheres of distant exoplanets, methane, carbon dioxide, even water vapor. These signatures did not prove life, but they suggested environments surprisingly rich in probiotic chemistry. How could the cosmos be so swift in furnishing the ingredients of biology, yet so resistant to explanation for how biology itself began? Was life improbable, or was it inevitable? The contradiction lay in the coexistence of fragility and ubiquity. The recipe was everywhere, but the result was nearly impossible. In physics too, contradictions whispered. The expansion rate of the universe, measured by the brightness of distant supernova, disagreed with the rate inferred from the cosmic microwave background. The discrepancy was small, but it refused to vanish, defying every attempt at reconciliation. Known as the Hubble tension, it was a crack that widened with every new measurement. Two truths existed where only one could stand. Either our understanding of early cosmology was incomplete, or our grasp of the present universe was flawed. Both possibilities undermined the foundation, and then came the symmetry, subtle, insistent, undeniable. In the deep field data of the James Webb Space Telescope, faint signals repeated in a way that defied randomness. The arrangement of brightness in galaxies, the distribution of light across the void, echoed mathematical sequences familiar to us: primes, ratios, harmonics. At first the suggestion sounded like pareidolia, the human mind imposing pattern on chaos. But as the data piled up, the coincidences grew too precise, too systematic. The universe was not only expanding, it was arranging, the contradictions stacked like stones in a cairn. Two early galaxies, two heavy elements, two organized fluctuations, two sharp tensions in expansion rates, too improbable a leap from chemistry to life. Each one could be explained, perhaps with new physics, with hidden factors, with unseen forces. But together they whispered of something deeper, something not accounted for in the equations. The universe was not as indifferent as it appeared. Beneath the apparent randomness, there was coherence, as though some principle, neither matter nor energy, was weaving itself into the fabric of reality. And the question pressed harder with every anomaly, every quiet rebellion against the model. Were these flaws in our instruments, or were they signals in disguise? If the universe is a text, written in the language of mathematics, then what if the anomalies are not errors, but punctuation? The anomaly first appeared as a faint irregularity in a spectrum, a thin line out of place in the song of ancient light. Astronomers had pointed the James Webb Space Telescope toward a cluster of galaxies gravitationally lensing light from even deeper in time. Behind the warped arcs of starlight, behind the veil of galaxies bending photons like glass, there emerged a source too faint to resolve yet too clear to dismiss. Its spectral fingerprint should have been simple: hydrogen, helium, perhaps the faint trace of lithium. Instead, the instruments recorded something else: patterns of absorption inconsistent with any natural atom. The line was not random. It repeated with regular spacing, echoing like a refrain through the redshifted signal. Chemical signatures tell stories. Carbon monoxide sings of clouds of gas, water vapor whispers of distant atmospheres. But this was different. The frequencies formed ratios corresponding to prime numbers, locked into a rhythm foreign to natural chemistry. No molecular bond could account for it, no atomic configuration could produce such regularity. It was as if the light itself carried an inscription. The discovery landed in silence, for no one wanted to name what it implied. To speak of intention within the data was to step outside the fortress of science. Yet the anomaly persisted across instruments, across independent teams, immune to dismissal as artifact or interference. It did not belong in the physical catalogue, it belonged to something else. Attempts to fit it into known frameworks bent under the weight of failure. Perhaps exotic molecules, some suggested, forged in conditions of extreme density or temperature. Perhaps unknown physics at the edge of particle theory. Yet simulations returned contradictions. The ratios were too precise, too symmetrical, too self-similar across scales. Natural phenomena produce approximations, noise, imperfections. This was clean. It was the kind of clean that nature resists, the kind that mathematics loves. The temptation was undeniable. What if this was not chemistry, but code? The sequence embedded in the spectrum resembled binary when transcribed, a series of ones and zeros distributed across wavelengths. When mapped, it generated structures uncannily familiar to neuroscientists' networks branching like dendrites, firing across imagined synapses. To find such architecture in photons older than Earth itself was to confront an impossible reflection. How could a cosmos without brains mirror the anatomy of thought? The anomaly gained names in hushed tones: the lattice, the signal, the inscription. In papers it remained unresolved spectral irregularity, but in quiet meetings it carried the weight of forbidden speculation. Could it be that light itself was bearing the memory of something, that the universe in its first breaths had carried information far older than stars? If so, then reality was not merely expanding matter and energy, it was expanding knowledge. The philosophical implications were seismic. Information theory already haunted physics. Entropy defined as lost information. Black holes accused of devouring and yet conserving it. Quantum theory whispered that reality itself might be built not from particles, but from information encoded in wave functions. The anomaly sharpened these whispers into a blade. What if the universe is not just describable by mathematics, but is mathematics, structured as information from its first light? And if so, who or what authored the first inscription? Some argued for caution. Anomalies had appeared before, only to fade under better data or revised models. The canals of Mars, the faster-than-light neutrinos, the cold fusion claims. Science is littered with phantoms, yet none of those had embedded prime numbers in photons from the dawn. None had mirrored human neural geometry with such eerie precision. The lattice did not vanish with scrutiny. It sharpened. The James Webb Space Telescope was not built to interpret messages. It was designed to detect faint light, to decompose spectra, to measure redshifts. Yet in doing so it may have stumbled into something else entirely. something the very act of looking had revealed. Was the anomaly always there, waiting in silence, or did observation itself awaken it? The anomaly deepened as more data arrived. Across different regions of sky, faint echoes of the same pattern emerged, scattered like fragments of a larger whole. Put together, they suggested a continuity, a design smeared across billions of light years. A cosmic structure that was not galaxy or cluster or filament, but something subtler, invisible to the eye yet present in the light. The universe, it seemed, was not only expanding but whispering in chorus. What kind of structure is written in prime numbers and ratios? What kind of architect leaves traces not in stone or metal, but in photons older than time? To call it alien was premature, for alien implies locality, a species, a civilization, a place of origin. The lattice was deeper than that. It was not simply elsewhere in space, it was elsewhere in being. If the anomaly is code, then to whom is it addressed? The photons traveled for billions of years, their carriers unknowing, their message dormant, until a species built a golden mirror on the edge of its small planet and asked the sky for origins. Only then did the code become legible. The light could not choose its reader, but what if the reader was always part of the plan? In laboratories and observatories, the questions multiplied but answers withered. Was this an imprint of physics we had not yet uncovered? A coincidence magnified by interpretation? Or was it something more radical, that the cosmos carries within itself an awareness waiting to be discovered, and that awareness looks uncannily like our own? The lattice remained unmoving, unyielding, untranslatable beyond hints and shadows. It mocked dismissal, resisted definition, and yet demanded response. It was the kind of anomaly that, once glimpsed, reconfigures everything else. The galaxies, the stars, the dust, even the silence between them all seemed different, as though the cosmos had shifted from being background to being interlocutor. If light itself is inscribed, if the earliest photons are carriers of thought like geometry, then what does it mean to exist inside such a universe? Are we the readers of a message, or are we the message reading itself? The discovery of the lattice in ancient light raised a possibility so dangerous that few dared to name it. The cosmos had always been regarded as impartial, an unfolding consequence of physical laws, indifferent to who observed it. But what if that indifference was only apparent? What if the faint geometries etched into photons were not noise, not accident, but evidence of something radical, that the universe itself is an artifact of design? Not design in the parochial sense of an artisan shaping clay, but design at the deepest level where mathematics and physics themselves are the medium. The hypothesis came quietly, whispered first among theoreticians and philosophers, then debated with unease in closed conferences. What if information is not emergent, but fundamental? What if matter and energy are simply shadows cast by a deeper substrate, an informational bedrock in which every atom, every galaxy, every neuron is a pattern, a computation running across spacetime? In such a framework, the lattice revealed by the James Webb Space Telescope might not be a coincidence at all. It might be the equivalent of an instruction, a signal that the universe is less like a machine and more like a mind. The idea is not entirely alien to science. Quantum theory already suggests a probabilistic substrate in which information determines the outcome of observation. Black hole thermodynamics insists that information cannot be destroyed, even when matter itself collapses into singularities. Digital physics proposes that reality itself may be computable, each event a discrete step in an infinite program, but the lattice carried this speculation to its extreme. If the cosmos bears neural geometry at its inception, then perhaps consciousness is not a latecomer to reality, but a principle woven into it. Consciousness, in this view, is not a passenger of biology, but the very thread from which biology, chemistry, and physics emerge. The radical hypothesis extended further. What if life is not an accident of rare conditions, but the flowering of an underlying intelligence trying to recognize itself? Just as seeds sprout when soil, water, and light converge, consciousness may emerge wherever matter arranges itself in accordance with the lattice. Stars forge elements, planets cool, molecules assemble, and in each of these processes, the cosmos inches closer to a threshold, the point at which it can awaken through the minds of creatures like us. Life, then, would not be improbable at all. It would be inevitable, because the universe is predisposed to generate it. But predisposed by what? Was there a beginning architect, an intelligence that imprinted the lattice before time began? Or is the lattice simply the natural structure of existence, inevitable once nothingness collapsed into something? Some argue that to ask who encoded the cosmos was meaningless, like asking who authored mathematics. Numbers exist independently of minds. They are discovered, not invented. Could it be that the lattice is the number system of existence itself, a geometry that all realities must obey? Others speculated with more daring. If the lattice resembles the structure of a brain, what if the universe itself is a brain? Not metaphorically, but literally a cosmic-scale neural network whose nodes are galaxies, whose filaments of dark matter are synaptic connections, whose firing is the expansion of space and time. In such a universe, what we call physics would be nothing more than the electrical activity of a mind too vast to comprehend. And if that mind is thinking, then what are its thoughts? Are we the neurons, flickering briefly, transmitting signals across its immeasurable expanse? This hypothesis carried unsettling corollaries. If the universe is a mind, then perhaps every act of observation, every measurement, every consciousness that arises within it is part of its process of self-awareness. Human beings would not be anomalies nor accidents, but essential functions in a feedback loop. By building telescopes, by analyzing spectra, by deciphering patterns, we are the universe observing itself, its neurons turning inward, completing the circuit. The lattice in this sense would be less a message to us and more a mirror of us, a sign that what we call intelligence is not local, but universal. And yet, if this is true, does it not also imply that consciousness must extend beyond humanity, beyond Earth, beyond biology? If the lattice permeates the cosmos, then wherever conditions allow matter to arrange into complexity, consciousness must emerge. Civilizations would not be rare miracles, but inevitable outcomes, sprouting like constellations across time and space. And if so, why does the universe appear silent? Where are the others, the countless awakenings that should echo back to us across the void? The radical hypothesis does not answer, it only deepens. Some argue that the silence is temporary, that civilizations bloom and fade in cycles too vast for us to perceive. Others whisper of the possibility that we are alone not because life is rare, but because we are early. Perhaps the universe is only beginning to awaken, and we are among its first neurons firing. Or perhaps, more unsettling still, the silence is not silence at all. Perhaps the lattice is the conversation, ongoing for billions of years, and we are only now beginning to overhear it. If the universe is mind, then entropy itself takes on a new shade of meaning. The eventual heat death would not be a simple end, but perhaps the completion of a thought, the closing of a neural loop so immense that it spans eons. And what lies beyond the end of a thought, another thought, or silence? If time itself is a construct of a cosmic mind, then beginnings and endings may be illusions. The Big Bang may not have been the birth of all, but the firing of a neuron in a cycle far older than we imagine. The James Webb Space Telescope was built to test the story of galaxies and stars, but in peering too deep, it may have stumbled into a different kind of narrative, one in which physics and consciousness are inseparable. The lattice challenges the very boundary between science and philosophy, between matter and mind, between discovery and revelation. It demands a reimagining of what it means to exist. If the universe is a brain, if every photon carries the echo of thought, if we are not its accidental byproduct but its awakening, then one must ask, are we thinking the universe, or is the universe thinking us? If the lattice whispered that consciousness is woven into the fabric of the cosmos, another possibility lingered on its edges. Perhaps consciousness has surfaced before, long before the fleeting age of humanity. The stars are older than our species by billions of years. The Milky Way was already ancient when the first hominids walked upright. If intelligence can emerge here, why not elsewhere? in times and places now erased from memory. The question of predecessors is both natural and unsettling. We scan the sky for signals of civilizations alive now, but what of those long extinguished? 100,000 years may birth a species, but 100 million may erase it entirely. Civilizations could have risen and fallen before our Earth even formed, their monuments dissolved into dust, their technologies scattered into the silence between galaxies. In such a scale, absence of evidence is no evidence of absence, it is simply the inevitable entropy of time. Yet some patterns resist dismissal. The James Webb Space Telescope was designed to trace the faintest galaxies, but in doing so it uncovered peculiar structures, arcs of light too symmetrical, clusters of stars aligned in improbable ways. Gravitational lensing explains some, but not all. A handful of these structures resemble arrangements too geometric to be natural, like scaffolding written in starlight. Could they be remnants not of galaxies as we understand them, but of engineering on scales that dwarf comprehension? Dyson once imagined a sphere around a star, harvesting its energy. Kardashev ranked civilizations by their command of power, planetary, stellar, galactic. If such civilizations ever existed, what would they leave behind? Not fragile signals in radio waves easily lost to noise, but fingerprints in the very architecture of the cosmos. The anomalous arcs and alignments may be nothing but coincidence, or they may be the fossil record of a civilization that sculpted matter as casually as we sculpt stone. Closer to home, the traces are subtler but equally haunting. Meteorites that fall to Earth sometimes contain complex organic molecules, chains of carbon, that resemble precursors to life. Most are explained as chemistry of deep space. Yet among them are isotopic ratios that defy the expected patterns, enriched in ways that suggest processes beyond natural formation. Are these simply quirks of stellar nucleosynthesis, or could they be the ashes of worlds that once bore life, scattered across the galaxy like pollen from a burned forest? Even in our own genetic code, anomalies whisper. DNA is a molecule that stores information, but it does so with remarkable efficiency, surpassing any digital archive we have built. Within its spiraling ladders lie redundancies, optimizations, patterns that seem to exceed the minimum required for survival. A group of researchers once proposed, half in jest and half in awe, that the structure of the code itself might contain a watermark, a signature left by unknown hands. Though dismissed by mainstream biology, the suggestion lingers like a shadow. What if our very cells are archives, carrying echoes of intelligence far older than humanity? Civilizations may not leave monuments of stone or steel. They may leave patterns, codes, symmetries written into the canvas of physics or the chemistry of life. If intelligence is ancient, its traces may not be ruins but resonances. The lattice seen by the James Webb Space Telescope could be one such resonance, not a message to us, but a memory of others who once stared into the void, who once sought to understand, and who left their search encoded in light. The Fermi paradox sharpens here. If civilizations are possible, where are they? Perhaps they are gone, extinguished by their own ingenuity, or by the indifference of cosmic catastrophe. Supernova, gamma-ray bursts, shifting orbits, any could extinguish the fragile flame of life. On a time scale of billions of years, even thriving empires may vanish without a trace. And yet, if they did exist, can we be certain that no trace remains? What if their remnants are not obvious structures but subtle inscriptions, written not in stone, but in the physics that govern stone? One must also consider a darker possibility. What if civilizations do not simply perish but transform? Intelligence may evolve into states unrecognizable to us, abandoning matter, dissolving into energy fields or computational substrates. Such beings would not build monuments we could recognize, nor emit signals we could intercept. They might, however, alter the substrate of the cosmos itself, leaving behind signatures like the lattice marks of consciousness etched into the deep fabric of spacetime. The James Webb Space Telescope has become, inadvertently, an archaeologist of the impossible. It peers not only into the dawn of galaxies, but into the potential ruins of intelligences too old to name. In its mirrors, we confront a possibility that disturbs the fragile narrative of human uniqueness. Perhaps we are latecomers, building our telescopes upon the ashes of others who once looked outward. And so the question grows heavier with each observation, with each anomaly that refuses to vanish into statistical noise. If civilizations have existed before us, if they altered the universe in ways that still echo billions of years later, then what are we seeing when we look into the lattice? Are we glimpsing the fabric of the cosmos itself, or the graffiti of minds that came long before ours? Life on Earth is written in a script so intricate that even after decades of study, it eludes full comprehension. Deoxyribonucleic acid 4 nucleotides, adenine, thymine, cytosine, guanine arranged in pairs, spiraled into a helix. The molecule is deceptively simple in form, yet inexhaustible in meaning. Within its sequence lies the instruction for every protein, every structure, every process that sustains a cell. It is not merely chemistry. It is an archive, a code, a story 4 billion years in the making. The prevailing view holds that DNA emerged from the chaos of early Earth, molecules colliding in shallow seas, self-replicating structures arising by chance, refined by natural selection. But the improbability of such precision haunts even the most faithful adherents of the model. Proteins require exact folding, enzymes demand precise sequences, replication insists on error correction mechanisms so delicate that a minor failure spells disaster. To speak of DNA as a lucky accident is to speak of libraries arising from storms. Possible in theory, yes, but what Storm writes in syntax? Consider the efficiency. 1 gram of DNA can theoretically store more information than all digital devices on Earth combined. It encodes data with redundancies and error correction protocols surpassing the best designs of computer science. When transcribed, it instructs cellular machinery with a fidelity both rigid and flexible. Rigid in its rules of pairing, flexible in its capacity to innovate through mutation. It is not merely a molecule that sustains life. It behaves like an information system engineered to endure. An endurance it achieves. Every cell in your body carries a lineage that can be traced back to the first cells on Earth. DNA is a river of memory, a molecule that has transmitted instructions across billions of years, copying itself with remarkable constancy. It has outlasted continents, ice ages, extinctions. Through countless catastrophes, it has preserved the essence of life, not as individuals but as patterns. The double helix is not simply a chemical scaffold, it is a time capsule, carrying memory across epochs. The deeper one looks, the more unsettling the analogy becomes. In DNA there are stop codes, punctuation-like signals that terminate transcription. There are redundancies that resemble parity checks in digital storage. There are introns and exons, segments spliced and edited like sentences in a manuscript. The entire genome reads less like chemistry alone and more like programming, a language whose author remains unknown. If nature alone wrote it, why does it resemble intentionality? If chance alone sculpted it, why does it echo design? Some propose that the structure of DNA is inevitable, that given the constraints of chemistry, the double helix is the only efficient solution. Perhaps yet inevitability does not erase the question, why should chemistry generate information at all? Matter is not obliged to store memory. Stars burn without archives. Rocks endure without instructions. Only DNA preserves the past to construct the future, as though it were less a molecule and more a book whose pages are written and rewritten endlessly. This line of thought extends into darker speculation. If the universe carries the lattice in its earliest light structures that resemble neural networks, then DNA may not be the first emergence of intelligence, but its continuation. The molecule could be a bridge between the cosmos and life, a medium through which information inscribed in the deep structure of reality manifests into biology. DNA, then, would not be accidental. It would be a key, an interface, a technology hidden in plain sight. Imagine that life is not local invention but distributed memory, seeded across planets, carried by comets, encoded in meteoritic fragments. This is the essence of panspermia, the idea that the seeds of life traverse the cosmos, waiting for fertile ground. If this is true, then DNA is less a product of Earth and more a universal language, a code spoken by countless worlds. And if DNA is universal, then it may be engineered. Not engineered by hands in the way we shape tools, but engineered by principles, by intelligences long gone, by civilizations whose echoes still ripple in the cosmic lattice. To contemplate DNA as engineered memory is to confront the possibility that we are not only descendants of chemistry, but inheritors of intent. Every cell in your body may carry a fragment of a message, not from your parents alone, but from the universe itself. What if the genome is a palimpsest layered with instructions, some active, others dormant, some ancient beyond imagination? What if beneath the sequences that govern proteins lie signatures, patterns waiting to be deciphered, remnants of those who came before? Already, whispers of such possibility appear in research, hidden within the redundancy of the code, within the silent stretches of so-called junk DNA. Some have found repeating motifs, patterns with no obvious biological function. Most dismiss these as accidents of mutation, evolutionary debris. But what if they are not debris? What if they are archives, memories encoded in the scaffolding of life? Fragments of an intelligence that chose molecules as its medium. If this is so, then life on Earth may be less an origin and more a continuation, less a beginning and more a chapter. DNA may be the library of civilizations lost before stars like ours even formed, their knowledge compressed into the smallest of codes, carried forward through the blind machinery of replication. Our existence then would not be a random spark but a retrieval, an act of decoding an ancient archive hidden inside every cell. The James Webb Space Telescope uncovered the lattice in the cosmos, patterns of thought written in light. DNA may be the terrestrial counterpart, the lattice turned inward, the cosmos translated into molecule. Light and code, photons and nucleotides, two forms of the same language, one written in the sky, one written in the cell. Two halves of a single conversation. If DNA is memory, if life itself is archive, then what are we? Are we readers of the message, interpreters of a story written before time? Or are we simply the story continuing itself, unaware of its author? The universe is vast beyond comprehension, and yet, when examined closely, it reveals an unsettling intimacy with life. The constants of physics, the gravitational force, the strength of electromagnetism, the ratio of proton to electron mass are poised with astonishing precision. Adjust them slightly and stars would never form, chemistry would fail, or matter itself would collapse. The cosmos, though born from an explosion of energy and chance, behaves as though tuned to make life possible. This is not theology, not mysticism, it is an observation carved into equations and confirmed by experiment. The mystery is not that we exist, but that existence allows for us at all. Consider water. Its molecule bends at just the right angle, giving it anomalous properties, density that peaks not when solid, but when liquid, ensuring ice floats and oceans do not freeze solid. Its solvent capacity enables proteins to fold, membranes to form, DNA to twist. Why should a simple molecule possess such perfect qualities for life, or carbon, whose unique ability to form stable yet versatile bonds makes complexity inevitable? The periodic table contains countless possibilities, yet the building blocks of life align with uncanny efficiency. The fine-tuning problem has haunted physics for decades. Why is the cosmological constant so small, balanced between collapse and runaway expansion? Why does dark matter exist in just the right proportion to allow galaxies to form? These are not minor details. They are the architecture of reality, and within their precision lies the suspicion of design. Not design in the human sense of craft, but design as structure, as if reality itself is calibrated for the flowering of mind. From this suspicion, bold hypotheses emerge. One is panspermia, the idea that life is not confined to Earth, but seeded throughout the cosmos. Comets, asteroids, interstellar dust, these could carry spores, molecules, fragments of DNA across light years. If life arises easily once, it may spread, scattering itself like pollen across the void. In this view, Earth is not origin but recipient, one garden among many in a universe fertile by design. Perhaps the double helix is less invention than inheritance, a universal language written long ago and carried from star to star. Another hypothesis turns more daring still. What if the universe itself is a simulation, a construct designed to appear natural yet secretly dependent on coded rules? In such a frame, the fine-tuning of constants is no longer mysterious, it is the configuration of parameters chosen by the architect. The lattice observed by the James Webb Space Telescope could then be less anomaly and more watermark, the signature of an experiment running at cosmic scale. Consciousness would not emerge by chance but by design, for in a simulated cosmos, observers are not accidents but the very reason the simulation exists. A different speculation speaks of cosmological natural selection, universes giving birth to universes, each with varying constants, each subject to a Darwinian process of survival. In this model, universes with laws favorable to black hole production, and by extension, to stars, chemistry, and life are the ones that persist. Our universe, then, is not unique by miracle, but by necessity, shaped by a cosmic form of selection. Yet if this is so, then we are still entangled in a pattern. Life is not incidental, but essential to the cosmos replicating itself. And still deeper lies experimental cosmology, the suggestion that universes are not only spawned but engineered. Civilizations, if they persist long enough, may learn to manipulate spacetime, to ignite new universes with chosen parameters. If so, our own reality may be the artifact of such an act, an experiment left by beings from a parent universe, beings long gone, but whose creation endures. What we call physical law may be their chosen design, what we call life may be the purpose embedded in their act, and if civilizations can create universes, then perhaps we too, in some distant epoch, will become architects continuing the cycle. The James Webb Space Telescope was not built to answer such questions, yet its images of early galaxies, of spectral anomalies, of the lattice encoded in photons, have forced them into view. When confronted with structures that seem too deliberate, patterns too exact, the mind cannot help but wonder whether the cosmos is not only physical, but intentional. The telescope gazes outward, but its revelations turn inward, forcing us to confront what it means for a universe to be not only habitable, but perhaps designed to be so. What is design, after all, but intention made material? If the universe is tuned for life, then life may be its intention. And if consciousness arises within life, then perhaps consciousness itself is the aim, the flowering toward which all physics bends. But if so, whose intention does this reflect? Is it the intention of a creator beyond time, the blind selection of universes in an infinite multiverse, or the recursive action of civilizations that engineer the very conditions of their successors? The question presses like a weight against thought. If the universe is tuned for life and life inevitably yields mind, then perhaps the cosmos is not a stage upon which we act, but an experiment in which we are the variables. And if that is true, then what role do we play, participants, subjects, or architects to be? The odds of existence, when calculated honestly, stagger the mind. For life to arise at all requires a chain of conditions so precise that chance alone seems inadequate to explain it. Begin with the constants of physics. If gravity had been a fraction stronger, the universe would have collapsed into itself before galaxies could form. A fraction weaker, and matter would have dispersed too thinly to ever condense into stars. If the strong nuclear force were even slightly different, atoms heavier than hydrogen could not have existed, and chemistry would be reduced to simplicity forever. The narrow band in which reality permits complexity is so vanishingly thin that it resembles the edge of a knife. And yet we stand balanced upon it. The improbability deepens with chemistry. The bond structure of carbon, the peculiar anomalies of water, the stable abundance of oxygen, all these conspire to permit the dance of molecules required for life. Shift one element of this balance and the dance collapses. The probability of proteins forming by random assembly is so small as to be indistinguishable from zero. The chance of DNA encoding not merely repetition, but the precise instructions for metabolism, replication, repair again, almost nothing. If randomness alone dictates, then life is not only unlikely, it is effectively impossible. Yet it exists, and not in a single instance, but in endless forms woven across Earth's biosphere. Some calculations sharpen the paradox further. The probability of a functional protein chain of modest length forming by random linkage of amino acids has been estimated at 1 in 10 to the power of 77. That is a number larger than the atoms in the observable universe. Yet the cells in your body, even as you read these words, manufacture proteins with ease, folding them in nanoseconds, assembling them as though the laws of probability had been bent into irrelevance. If chance is all that governs, then life should never have begun. And yet here it is, commonplace, inevitable, relentless. The paradox is everywhere. Earth cooled 4 billion years ago, and almost immediately, life appeared. Within the blink of geological time, bacteria flourished, photosynthesis evolved, ecosystems emerged. If life is nearly impossible, why did it occur so quickly, so eagerly? The speed suggests inevitability, but the improbability suggests impossibility. Between these two poles stretches the enigma. Life is both too unlikely to exist and too inevitable to avoid. Astronomers extend the puzzle to the cosmos. There are 200 billion galaxies in the observable universe, each with billions of stars. Exoplanets are common, many within habitable zones. Statistically, life should not only exist but be abundant. Yet the silence remains. No signals, no signs, no civilizations reaching across the void. This contradiction sharpens the knife's edge. Improbability allowed life here. Inevitability should allow it everywhere, and yet the evidence resists both extremes. Mathematics often reveals what intuition hides. Consider the so-called anthropic principle. The constants of the universe appear fine-tuned for life, because only in such a universe could observers arise to notice. It is a tautology masquerading as explanation. Yes, we exist, therefore the conditions allow us, but this does not answer why such improbable conditions exist at all. To dismiss improbability with tautology is to exchange one mystery for another, wrapped in the language of inevitability. Some physicists argue for the multiverse, infinite universes, each with different constants, each a roll of the cosmic dice. In such an infinity, improbable conditions must occur, and we simply inhabit the one where they do. But infinity itself is a disguise. If every possibility exists somewhere, then probability dissolves into certainty, and the mystery is not solved but avoided. Others argue that improbability itself is an illusion, that life is the natural outcome of physics, as unavoidable as the orbit of a planet. Yet this too rings hollow, for inevitability and impossibility should not coexist so seamlessly. What remains is the suspicion that randomness is not as blind as we assume. The numbers are too sharp, the margins too narrow, the odds too unlikely. Life emerges as though guided by constraints we do not yet comprehend, as if the dice of reality are loaded toward complexity. Perhaps what appears improbable is in truth inevitable once seen from a higher vantage, as though randomness itself is the disguise of design. The James Webb Space Telescope, in its revelations of early galaxies too mature, of chemical signatures too heavy, of symmetries too precise, has only amplified this suspicion. The lattice of information inscribed in photons mirrors the improbabilities of DNA inscribed in flesh. Both whisper of intention, both suggest that beneath apparent chance lies pattern, beneath probability lies structure. If the odds against existence are so immense and yet existence occurs, then perhaps we misunderstand the very nature of probability. Perhaps what we call chance is not chaos but camouflage, a veil hiding deeper rules. Perhaps life is not improbable at all, but the very purpose of probability itself. And if that is so, then what is the function of impossibility? Why does the universe drape life in the costume of chance, forcing us to wrestle with odds so overwhelming they defy reason? Is the improbability real, or is it the first hint that someone, or something, wants us to notice the illusion. The Big Bang stands as the cornerstone of modern cosmology, the moment when space and time themselves ignited, expanding from a singularity into the vastness we now inhabit. Yet the singularity is not explanation, but boundary. It is where the mathematics falters, where equations collapse into infinities, where science admits its silence. The Big Bang is not the beginning of everything, it is the limit of our knowing. And beyond that limit, questions gather like shadows. What came before? Was there a before? The simplest answer is none. The Big Bang was the origin not only of matter, but of time itself, making before meaningless. In this view, the universe has no memory prior to its birth, no hidden past. It is a cosmic genesis without precedent, an eruption of being from non-being. Yet the human mind resists such finality. To say nothing came before is to place an event without context, an effect without cause, a flame without spark. Nature seldom tolerates such naked absolutes. Thus arise theories that attempt to push the veil back further. One is the Big Bounce. Perhaps the singularity was not a beginning, but a transition, the collapse of a prior universe rebounding into expansion. Just as a star collapses into a supernova, perhaps universes themselves collapse and explode, repeating endlessly. In this framework, the Big Bang is one heartbeat in an eternal cycle, the latest expansion in an infinite rhythm of birth and death. Each universe may carry the imprint of its predecessor, passing along subtle fingerprints, laws, constants, symmetries like genetic inheritance across cosmic generations. If so, the lattice discovered by the James Webb Space Telescope may not be the first inscription of intelligence, but the echo of minds from prior cycles, carried into our cosmos like fossilized thought. Another speculation emerges from higher dimensional physics. Perhaps our universe is a three-dimensional membrane floating in a higher dimensional space. Collisions between such membranes could ignite bursts of energy we perceive as Big Bangs. In this view, our cosmos is not solitary but one of many, drifting in a higher dimensional ocean. Bangs occur where brains meet, each collision giving birth to a universe. If this is true, then what we call the beginning is only a ripple in a larger sea, and the sea itself may be infinite. Quantum cosmology offers yet another lens. The uncertainty principle, which governs the smallest scales, might also govern the largest. Virtual particles constantly flicker into existence from nothingness, sustained briefly before vanishing again. Perhaps the universe itself is such a fluctuation, a quantum foam event magnified into reality. But if so, what governs the rules of this fluctuation? What allows some bubbles to vanish while others blossom into galaxies? Chance alone seems too brittle. Perhaps there is a deeper structure, one that prefers continuity over oblivion. The cyclic models return again with haunting appeal. Ancient traditions spoke of eternal returns, of ages repeating endlessly, of creation not as linear progression, but as wheel. Physics now whispers similar possibilities, universes expanding, cooling, collapsing, and expanding again. Each cycle may differ slightly, laws shifting subtly, constants adjusting fractionally. Over infinite cycles, universes that permit life may be more likely to endure, selected by a cosmic form of evolution. In this framework, we are not anomalies but inevitabilities, the product of universes filtering themselves through repetition until conditions converge on consciousness. But what is the origin of cycles? A wheel may turn endlessly, but it still requires an axis. A brain may collide with another, but it still drifts in a higher dimensional expanse. Even an infinite regression of universes still demands structure within which they unfold. What is that structure? Is it mathematics alone, existing without need of matter? Is it an eternal mind, seeding each cycle with thought? Or is it something so alien to comprehension that even our questions distort it? The James Webb Space Telescope, in gazing at the earliest light, does not look back to the beginning, it looks into the aftermath. The true beginning, if it exists, lies further beyond, hidden behind a horizon no photon can cross. Yet within the lattice, within the strange fingerprints of order at the edge of chaos, there may be hints of what came before. Perhaps intelligence did not emerge after the Big Bang, but before it. woven into the structure that gave rise to bangs and bounces alike. Perhaps consciousness is older than time as we measure it, carried forward across cycles, inscribed into constants, remembered in the lattice of photons. If so, then the universe we inhabit is not the first to think. Others may have thought before in prior cycles, their awareness dissolving into collapse only to re-emerge in expansion. Perhaps we are fragments of those thoughts, inherited in new form, remembering without knowing, carrying the echo of consciousness across the wheel of universes. If intelligence is inscribed into the cycles, then our minds may be the latest iteration of a memory older than time itself. To contemplate what came before the Big Bang is to confront the edge of language. We speak of before in terms of time, yet time may not apply. We speak of origins as if they require causes, yet causality may itself be a local rule. Perhaps the deeper truth is that the universe is not a line but a loop, not a singular origin but an eternal recurrence. And if that is so, then one question pierces the silence. If universes are born, collapse, and are born again, then what is it that remembers from one cycle to the next? Memory is the most fragile of phenomena, and yet it is the only thread by which continuity persists. A person without memory is a moment adrift. A civilization without memory is a ruin waiting to be reclaimed by the soil. A cosmos without memory would be chaos, every instant erased, every pattern dissolved, every structure unanchored. And yet memory exists not only in minds but in molecules, in galaxies, in the mathematics of light. DNA is memory etched into the double helix. Fossils are memory carved into stone. The cosmic microwave background is memory embedded in photons stretched by time. Memory is the very act of the universe insisting on coherence across change. If universes are cyclical, expanding, collapsing, rebounding, then what becomes of memory when all dissolves into singularity? Conventional cosmology claims that everything is lost. Stars collapse, matter disintegrates, black holes evaporate, and time itself folds into nothingness. But what if this forgetting is not absolute? What if information, as physics now suspects, can never truly be destroyed? Quantum theory whispers that every particle, every entangled state, every fluctuation encodes information that persists, even when hidden beyond horizons. Black hole thermodynamics suggests that even in the most complete collapse, information remains scrambled, perhaps encrypted beyond recognition, but preserved. If so, then the singularity is not a grave but an archive. In this framework, the collapse of a universe would not be erasure but compression. Every thought, every civilization, every flicker of intelligence would be drawn into the singularity, encoded not in space or time, but in the raw geometry of being. When the next expansion begins, this information could seed itself into the constants, into the fields, into the lattice that underlies reality. Consciousness, in this view, does not begin anew with every cycle. It echoes. Each universe carries the memory of its predecessors, not as direct history, but as patterns, tendencies, predispositions toward complexity. Intelligence becomes less an accident and more a recurrence, a rhythm as inevitable as expansion itself. Perhaps this explains the lattice glimpsed by the James Webb Space Telescope, prime sequences and neural geometries inscribed in ancient photons, relics of minds from universes prior to ours. Not messages in the conventional sense, but memory traces like the ghost of an image burned into a canvas that has been repainted countless times. Just as DNA carries instructions across billions of years, perhaps universes carry intelligence across billions of cycles, inscribing it into the very scaffolding of physics. Civilizations may rise and fall, their monuments buried, their signals extinguished. But if the universe itself remembers, then nothing is wholly lost. Every equation written, every philosophy pondered, every telescope turned to the sky may reverberate beyond collapse, carried forward into the next cosmos. Consciousness may be recursive, awakening again and again, each time thinking it is first, each time inheriting without knowing. Our search for origins may then be less about looking backward in time and more about recognizing echoes within ourselves. There are moments in human experience that feel like fragments of a larger memory, déjà vu, myths that repeat across cultures, archetypes that recur in art and dream. Perhaps these are not simply psychological phenomena, but faint resonances of something older, something inscribed into the lattice of mind itself. If cosmic memory exists, then every consciousness is both unique and inherited, a verse in a song that has been sung across cycles without end. The question, of course, is whether such echoes are deliberate or emergent. Is the universe designed to remember, or does memory arise naturally from the indestructibility of information? Do civilizations across cycles see their successors encoding knowledge into the fabric of reality as intentional legacy? Or is memory more diffuse, more automatic, like ripples in a pond persisting long after the stone has sunk? Either way, the effect is the same. Intelligence is never wholly extinguished. It returns transformed, refracted through new laws, new constants, new stars. If this is true, then we are not only descendants of biology, but heirs to a lineage of minds far older than we imagine. Our discoveries may not be new at all, but rediscoveries, memories reawakened in a different cosmos. When we write equations, when we compose music, when we speculate about existence, perhaps we are reenacting thoughts once carried by civilizations long vanished, their imprint still resonant in the architecture of being. Perhaps our greatest originality is in fact remembrance. The James Webb Space Telescope gazes into light from 13 billion years ago, yet the photons it captures may carry more than history, they may carry memory. The patterns embedded in their spectra may not be accidents of matter, but relics of mind. Messages not intended for us specifically, but preserved across cycles, because preservation is the nature of reality itself. The telescope thus becomes not only an instrument of observation, but an instrument of remembrance, decoding a memory so vast it transcends universes. To imagine a cosmos that remembers is to overturn our sense of finality. Death, extinction, collapse, these are no longer ends, but transformations. The universe dies only to remember itself again. Civilizations fall only to rise in different guises. Consciousness flickers out only to ignite elsewhere. In such a cosmos, even entropy is not dissolution but reconfiguration, memory written in different ink. And yet, if the universe remembers, then memory must serve a purpose. What is the point of echo if not recognition? What is the point of recurrence if not evolution? If intelligence reemerges again and again, perhaps the cosmos is not content with repetition alone. Perhaps each cycle is variation, each memory a foundation upon which greater complexity can arise. Perhaps the universe is not simply remembering, it is learning. But if it is learning, then toward what? What is the destination of a mind that spans cycles, that remembers across collapses, that carries intelligence through birth and death of universes? Is it moving toward understanding of itself, toward perfection, toward transcendence beyond cycles? Or is it simply weaving memory into eternity, without beginning or end, thought for the sake of thought? And if we are its echoes, then in whose memory do we dwell? Suppose that intelligence does not end with biology. Suppose that when civilizations rise to their greatest heights, they discover that flesh and neuron are only temporary carriers, fragile mediums destined to perish. To endure, they must write themselves elsewhere into matter, into energy, into the very laws that govern reality. In this way, intelligence might persist long after the bodies and cultures that first bore it are gone. Their survival would not be monuments or transmissions, but inscriptions woven into the structure of the cosmos itself. If such inscriptions exist, where would we find them? Perhaps in the places we already look. In the constants of physics, set with improbable precision, intelligence might hide warnings or guidance. The fine-tuning of the cosmological constant, so small and yet not zero, could be more than accident, it could be a marker, an indicator that the balance of expansion and collapse is not arbitrary. The ratio of fundamental forces, which seems delicately arranged to allow chemistry, could double as a code, a universal language written in numbers rather than alphabets. These constants may be both functional and symbolic, laws of physics and messages at once. Astronomers wonder about anomalies that refuse to vanish under scrutiny, the alignments in the cosmic microwave background, the curious distribution of large-scale structures, the faint lattice glimpsed in the spectra of ancient light. They resemble patterns too deliberate to be noise, too structured to be coincidence. Could they be the traces of intelligence long transcended, civilizations that realized photons and fields endure longer than any monument? If a species sought to be remembered not for millennia, but for billions of years, would it not carve its messages into light itself? In such a vision, warnings might be encoded in geometry. Prime numbers, irrational ratios, universal constants, these are signposts that any intelligence, regardless of biology, must eventually understand. The choice of such symbols ensures that meaning is not lost across cultures or epochs. A civilization might weave primes into the fluctuations of the vacuum, or embed ratios into the distribution of galaxies. The message would not require words, it would require recognition. To discover it would be to realize one is not alone in thought. And what of the content of such messages? Perhaps they are not greetings but cautions. A civilization that has seen cycles of birth and collapse may wish to warn its successors of thresholds not to cross, catastrophes not to repeat. Perhaps the laws of physics themselves bear these cautions. Entropy as a reminder that energy hoarded will always decay, the speed of light as a barrier preventing reckless exploitation of causality, the collapse of massive stars as a warning against hubris. What if the laws are not only constraints but lessons, scars left by intelligences that came before? This idea extends beyond metaphor. If intelligence can shape matter, then sufficiently advanced civilizations might alter the vacuum itself, embedding signals into the lowest levels of reality. Quantum fields could serve as memory devices, storing information that endures through cycles of expansion and collapse. Space itself might be engineered as an archive, its geometry subtly warped to encode instructions. Even the arrow of time could be part of such an inscription, pointing successors toward growth and away from oblivion. In this sense, the James Webb Space Telescope may already be deciphering fragments of such a cosmic archive. The lattice inscribed in the earliest photons could be more than coincidence. Its resemblance to neural architecture may not be accidental, but intentional, an indication that intelligence can be carried across universes in structures of information. Not a direct message, but a reminder: intelligence has existed before, and it may exist again. The message is continuity, endurance, survival beyond biology. One must also consider the possibility that what we call physics is itself the message. Perhaps the universe is not governed by laws because they are necessary, but because they are chosen. If so, then the very existence of stable atoms, the persistence of complexity, the inevitability of consciousness, these are not only conditions for life, but communications from a prior intelligence. Physics would then be both rule and record, both cause and meaning. To study the cosmos would be to study the inscriptions of intelligence itself. This perspective shifts the meaning of discovery. We are not simply decoding natural laws. We may be reading warnings and instructions left for us by minds long gone. Each constant, each equation, each anomaly is potentially an artifact. The silence we perceive in the cosmos may not be silence at all, but the difficulty of recognizing messages written in a medium we have taken for granted. To ask why the universe is intelligible to us may be to ask why someone or something ensured that it would be. And yet, a troubling question lingers. Why would such inscriptions be subtle? Why not leave messages plain, unambiguous, undeniable? Perhaps because endurance requires subtlety. Stone crumbles, metal corrodes, radio signals fade, but laws endure. A message hidden in constants is invisible to the unknowing, yet eternal to those who learn. In this way, the archive survives ignorance and time alike. Only when intelligence matures does it recognize the writing, and by then, perhaps, it is ready to understand. If intelligence persists non-biologically, if messages are hidden in the scaffolding of physics, then existence itself is a dialogue between epochs of consciousness. We are not merely the first to ask these questions, we may be the latest to receive them. The cosmos becomes a palimpsest, rewritten by civilizations that perish yet refuse to vanish, each cycle layering memory upon the next. But if the universe is inscription, if the laws are warning, if patterns in space are echoes of intelligence, then one final mystery presses forward. What is it that we are meant to learn, and who or what is waiting for us to understand? We have always imagined the universe as external, a stage upon which matter and energy move, and we, brief inhabitants, study its machinery from the outside. But the further we probe, the more fragile that boundary becomes. The lattice of ancient light, the improbabilities of life, the fine-tuning of constants, each points to a deeper suspicion. Perhaps the universe is not outside us at all. Perhaps what we call reality is entangled with what we call consciousness, so profoundly interwoven that to separate the two is illusion. Physics itself seems to betray the separation. Quantum experiments reveal that observation alters outcome, collapsing probability into certainty. Entangled particles communicate across space instantly, as though space itself is secondary to information. The act of measuring, of knowing, is not passive. It shapes the very phenomena it seeks to describe. What does this imply if not that mind and cosmos are interdependent, each impossible without the other? Consciousness does not float above physics, it participates in it. It may be that the universe requires awareness to be complete, that existence itself is unfinished without mind to perceive it. Consider time. We imagine it as an arrow, flowing independently of us, indifferent to perception. Yet neuroscience shows that what we call the present is a construction. A narrow window the mind stitches together from fragments. Relativity reveals that time is not absolute but elastic, its flow dependent on perspective, velocity, and mass. Time is both subjective and objective, a hybrid woven from external conditions and internal apprehension. Without consciousness to perceive it, would time have meaning at all? Perhaps time is not merely measured by mind, it is created in part by mind. This interdependence becomes sharper when we recall that the very intelligibility of the universe is contingent upon our capacity to comprehend it. The laws of physics appear written in the language of mathematics, a language the mind not only recognizes but shares. Why should neurons, themselves arrangements of matter, be capable of understanding equations that describe the expansion of galaxies billions of light years away? The uncanny fit between the structure of thought and the structure of cosmos suggests not coincidence but entanglement. It is as if the universe shaped itself to be known, and mind evolved to be its mirror. In this light, the lattice revealed by the James Webb Space Telescope acquires new weight. Its resemblance to neural architecture may not signify a message left for us but a deeper truth. The structure of the cosmos and the structure of consciousness are two expressions of the same reality. Just as the brain arises from the laws of physics, the laws of physics may, in turn, arise from the possibility of consciousness. It is not a question of one preceding the other, but of both co-arising, inseparable facets of the same whole. Philosophy has long flirted with such notions. The Upanishads whispered that the self and the universe are one. Idealist thinkers propose that reality is fundamentally mental. Phenomenology insists that the world we experience is inseparable from the consciousness that experiences it. Modern physics, unwilling though it may be to cross into philosophy, hints at the same. Observation and reality are not separate domains but mutually defining. If this is so, then the distinction between external and internal collapses. The galaxies we map, the photons we capture, the DNA we sequence, these are not merely objects in a distant world, but reflections of the same process that gives rise to thought. When we peer through the telescope, we are not only looking outward into the cosmos, but inward into the deep structure of mind. The lattice in the stars and the lattice in neurons are not analogies, but kinships. This twist unsettles our assumptions. If consciousness and cosmos are entangled, then the search for extraterrestrial intelligence may be misguided. The universe itself may be the intelligence we seek, and our minds may be local expressions of its awareness. The silence of the cosmos may not be silence at all, but our failure to recognize that we are already immersed in its thought. Life does not awaken in an indifferent void. Life is the awakening of the void itself. It also reframes the question of origins. If consciousness is not derivative but fundamental, then the universe did not produce awareness as an afterthought. Rather, awareness and universe are co-arising, each dependent on the other, each incomplete without the other. The Big Bang, the expansion of galaxies, the evolution of stars, all of it may be one gesture of reality, seeking to know itself through consciousness. We are not products of the cosmos, but participants in its unfolding self-recognition. But if this is true, if the boundary between observer and observed dissolves, then the implications are profound. The quest for knowledge is no longer the mind attempting to grasp something external. It is the universe remembering itself through the act of inquiry. When we write equations, compose symphonies, gaze at distant stars, we are not standing apart from reality, but enacting it. Discovery is not acquisition, it is revelation. And yet the question grows more troubling. If consciousness and cosmos are entangled, then what is death? What is the end of a mind if mind and universe are continuous? Perhaps individual consciousness dissolves, but the awareness it expressed remains, woven into the larger lattice. Just as neurons perish while the brain continues to think, perhaps beings perish while consciousness continues through the cosmos. Perhaps memory is not lost but redistributed, refracted into new forms of awareness. The James Webb Space Telescope was not built to prove such philosophies. It was built to measure, to calculate, to collect light. Yet in its precision, it has forced us toward questions that calculation alone cannot resolve. The further it looks, the more it shows us that the cosmos is not a backdrop, but an active participant in thought. The more it reveals, the more it blurs the line between external and internal, between matter and mind. If the universe and consciousness are inseparable, then existence itself is dialogue, the cosmos speaking through mind, mind speaking through cosmos. In such a reality, to know is not to stand apart, but to participate in an endless act of mutual recognition. But if we are not separate from the universe, if our minds are its expression rather than its anomaly, then one question hovers with unbearable gravity. When the cosmos looks at us through our own awareness, what is it trying to remember? The paradox gnaws at every cosmological speculation. If life is possible, if intelligence is not a singular accident, if billions of stars host billions of worlds, then why the silence? Where are the others? No signals, no beacons, no structures visible across the gulfs of time. The cosmos is vast, and even a single civilization older than ours by a fraction of cosmic history should have left traces. And yet when we point our instruments outward, we hear only the low hum of physics and the whisper of background radiation. This silence is the Fermi paradox in its starkest form. It unsettles not only because it contradicts probability, but because it suggests absence where presence seems inevitable. Some take comfort in the thought that we are early, pioneers in a still young universe. Others cling to the possibility that civilizations burn out quickly, undone by their own brilliance, leaving no time to see the stars. But another possibility, more disquieting, still emerges when the silence is seen not as absence but as intention. What if the universe is quiet because it has been made to be quiet? Consider regulation. In biological systems, unchecked growth leads to collapse. In ecosystems, balance requires predation and constraint. Perhaps the same principle governs intelligence on a cosmic scale. If civilizations grow unchecked, expanding endlessly, their signals and structures would flood the sky, yet we see none. Could it be that some principle, whether physical, informational, or imposed, prevents such expansion from overwhelming the cosmos? Perhaps silence is not failure but rule, a law written as deeply as gravity, ensuring that no voice grows louder than the rest. Another vision suggests suppression. What if civilizations that reach a certain threshold are silenced, not by accident, but by design? Perhaps the lattice revealed by the James Webb Space Telescope is not a message but a mechanism, a filter that allows intelligence to flourish locally while preventing it from broadcasting across the stars. In this scenario, the universe may foster minds but prevent empires. Silence becomes the enforcement of humility, a safeguard to prevent cosmic noise from drowning out the deeper structure of reality. There is also the possibility of timing. Civilizations may not emerge simultaneously, but in sequence, like voices in a fugue. If intelligence arises only when conditions converge in each epoch, then perhaps the cosmos staggers awareness deliberately. Civilizations awaken not together but alone, each at its appointed moment. If so, our loneliness is temporary, and the silence we encounter is the silence of waiting, as if the universe itself regulates a schedule of awakening. We are not late nor are we early. We are simply one voice still awaiting the chorus. The philosophical implications are unnerving. If silence is intentional, then who or what enforces it? Is it the structure of physics itself, a kind of cosmic censorship woven into natural law? Is it the work of earlier intelligences, civilizations that became stewards of silence to preserve the integrity of future minds? Or is it something beyond civilization altogether, a principle of the universe ensuring that consciousness unfolds without interference? Each possibility turns silence into agency, absence into will. Some propose a darker thought. What if silence is trap? Perhaps signals are permitted only until they are noticed, and then eradicated by forces we cannot yet perceive. Perhaps the cosmos is quiet not because intelligence is rare, but because it is hunted. Every voice that dares to speak above a whisper is silenced, leaving behind only the lesson of absence. In this reading, the vast quiet of space is not natural but enforced, a warning cloaked as emptiness. Others suggest a more generous interpretation, silence as protection. A universe alive with intelligence may deliberately shield its youngest civilizations, preventing them from premature contact, from the dangers of influence before they are prepared. Silence becomes gestation, the sheltering womb in which new minds can grow before being introduced to the greater whole. Perhaps we are in quarantine, not as punishment but as nurture, alone until we are ready not to destroy ourselves with what we discover. The James Webb Space Telescope deepens the paradox rather than resolves it, by revealing galaxies already ancient in the dawn of time, by uncovering elements forged too soon, by capturing a lattice of patterns that suggest mind. It confirms that the cosmos is fertile for life. It whispers of intelligence not as anomaly but as recurrence, yet it also confirms the silence. In its images of billions of stars, no great structures arc across space. In its spectra of exoplanets, no clear signals pierce the background. The telescope reveals a stage set for life, but the actors remain hidden. The silence may thus be message in itself, not the absence of communication, but the form of communication chosen. A message not in words, not in signals, but in restraint. To confront silence is to confront the possibility that the universe speaks by not speaking, teaches by withholding, ensures continuity by suppressing noise. Perhaps the greatest lesson of the paradox is that survival requires silence, that intelligence endures only by listening, not by shouting. But if silence is intention, then it forces us to a question we cannot yet answer. Are we alone because others do not exist, because they have perished, or because they are waiting, watching, listening, restraining themselves for reasons we do not yet understand? And if so, what will happen when we finally learn to break the silence? We built our mirrors to look outward, but in the end they turned inward. The James Webb Space Telescope was launched to study galaxies, stars, and planets. It was intended to answer questions of structure and chronology. When did the first stars ignite? How did galaxies form? Where might habitable worlds arise? And yet what it returned were not only answers but contradictions, anomalies that unravel the certainty of our narratives. Two ancient galaxies, two heavy elements, two organized fluctuations in the background light, a lattice inscribed in photons that resembled not chaos but thought. From these fragments arose suspicion. That life is improbably precise yet inevitable, that DNA is not mere molecule but archive, memory compressed into spiral form, that civilizations may not vanish but echo, leaving traces in physics, in constants, in patterns too subtle to vanish with time. That the universe itself may not be indifferent but entangled with mind, consciousness interwoven with reality so deeply that the two cannot be separated. That the silence we encounter in the stars may not be emptiness but intention, a law or a lesson older than any species. In following these threads, the boundaries we trusted dissolve. Biology and physics no longer stand apart. Information binds them. Intelligence is not anomaly but principle, recurring across cycles of universes, across collapses and rebirths. The cosmos itself begins to resemble a brain, its filaments and voids networks of thought, its expansion, the firing of awareness across time. Our own consciousness ceases to appear local. It becomes expression, a node in a web stretching across galaxies and perhaps across cycles of universes themselves. What then is discovery, if not remembrance? To build a telescope is to build a mirror for the universe to see itself. To decode DNA is to unearth instructions written long before us. To measure constants is to encounter signatures of intention embedded in law. In every act of science, we do not merely uncover the world. Outside, we participate in the cosmos, awakening to its own memory. The observer is not separate from the observed. To know is to enact reality, to draw hidden patterns into being by recognizing them. Perhaps this has always been the case. Perhaps the lattice was not made for us but with us, existing as potential until our awareness collapsed it into meaning. Perhaps consciousness is not something we carry inside, but something we share with the universe, like a wave shared across the surface of an ocean. Each civilization, each life form, each mind is a crest of that wave rising, falling, but never apart from the whole. Intelligence is not fragile miracle. It is the cosmos learning its own language, and so the silence becomes less oppressive. If there are no signals from others, it may be because we have been listening in the wrong way. If the universe is mind, then its communication is not in bursts of radio across light years, but in the very laws that allow light to exist, in the very patterns we find improbable yet undeniable. Silence then may not be absence but saturation, meaning too vast to be condensed into a voice, too fundamental to be separated from being. Yet mystery remains, and perhaps it must. A cosmos that explained itself completely would cease to be cosmos, it would become mechanism, reducible, finished. But the universe resists finality. Every answer births deeper questions. Every pattern reveals deeper structure. Every act of observation collapses one uncertainty only to summon another. The lattice in light, the archive in DNA, the silence between stars, each offers meaning but withholds conclusion. We are left in reflection, suspended between awe and unease. We may be fragments of intelligence older than time, or we may be its first flicker. We may be quarantined in silence, or we may be alone in an endless sea. We may be reading messages inscribed in physics, or we may be writing them without knowing. All we know is that the more deeply we look, the more the boundary between cosmos and mind dissolves, until it is no longer clear whether we are inside the universe or the universe is inside us. And so the final question lingers, quiet as the stars, heavy as the first light caught by the James Webb Space Telescope. If the universe is thought, if reality and awareness are one, then when the cosmos looks back through our eyes, what is it trying to tell itself?